In this video, I will introduce a basic principle on irrigation water management that has the potential for profound impact on water use in production agriculture. That is the topic of managing irrigation to maximize profits. Standard irrigation management practices typically manage for maximized yield, mitigated risk, irrigation system capacity, or some combination of these parameters. For our purposes in this video, we will look at production cotton in the Texas Panhandle, specifically north of Interstate 40. One of the primary reasons for cotton's growing presence in the Texas North Plains is that it is one of the most water use efficient crops grown in production agriculture. It is also relatively versatile to multiple cropping systems. In order to get the most out of cotton in a production setting, sound irrigation decisions will promote a healthy balance between reproductive and vegetative growth, allow for in-season and late-season growth regulation, and greatly increase yields. The most effective measure for making these decisions is through profit-based management and an understanding of cotton water use characteristics. Profit is simply expressed by this equation: total revenue minus total expenses. In agricultural production settings, we maximize the revenue by increasing yield, and we minimize expenses by controlling our inputs. For cotton, like all other crops, yield is directly related to the inputs. Therefore, it takes solid management decisions to optimize profits. For this example, we will use a total lint price of 60 cents per pound and a cotton seed price of $180 per ton. The backbone to understanding cotton water use is this graph, which is commonly referred to as a production function. This production function demonstrates the expected lint yield as a function of seasonal total water applied. The numbers on the x-axis represent a combination of irrigation, soil storage of off-season precipitation, and in-season rainfall. For cotton in the Texas North Plains, it is very evident that additional water added provides an increase in yield, almost linearly until the genetic or environmental yield potential of the crop is reached. At this point, the yield plateaus with additional water and then begins to decrease. The decrease is caused most commonly by saturation effects that hinder the soil oxygen-water balance in the plant root zone. This is commonly referred to as waterlogging. Specific to cotton, increased irrigation may also cause the crop to be excessively vegetative, which also hinders yield. In a typical production setting, the peak yield occurs at about 19 inches of total seasonal water, or roughly 9 inches of applied irrigation water. If we take the information from the production function and analyze it for incremental yield gained per inch of water applied, we see that each subsequent inch of water after about 12 inches returns a less significant incremental yield than the previous inch. This is referred to as the law of diminishing returns, just like basic economics. The peak of this curve occurs at about 12 inches, which is the point of maximum water use efficiency. However, production agriculture is not paid on the margin of water use efficiency. Therefore, it is necessary to evaluate cotton's water use characteristics on a financial basis in order to make sound management decisions. The production function and incremental yield information takes on a very meaningful shape when combined with an honest crop budget. The curve shown makes use of budget data extracted from the 2010 Texas AgriLife Extension Service cropping budgets to demonstrate incremental profit values for each subsequent inch of water. The most profitable use of the water resource, incrementally, occurs at 15 inches of total water. In years of low input costs and high commodity prices, this point will move toward the max yield point. In years with high input costs and low commodity prices, this point will shift left on the curve towards minimum inputs. In this example, cotton shows a peak return of about $15 per total inch of water. For comparison, grain corn in the Texas North Plains has a peak incremental return of about $12 per inch. Again, however, crop production success is not measured by incremental indicators. In order to completely apply profit-based irrigation management, we must look at our management comprehensively on a profit per acre basis, our final measure of efficiency. In the Texas North Plains, the profit per acre per inch of water curve is very symmetrical about the maximum profit point of 18 inches of total water applied. If you will recall, the maximum yield occurs at 19 inches of total water. Since cotton is a very efficient water user, it is sensible that the maximum profit corresponds to a point very close to the maximum yield. This is a production trait that is generally unique to cotton. The irrigation requirement to maximize profit on cotton is typically between 6 to 10 inches annually. It cannot be overstated at this point that irrigation management and application timing are very critical when targeting specific irrigation levels. The final take-home point on this topic is that there are multiple points on this curve that correspond to the same profit level. This dispels the common thought that an extra inch of water is cheap insurance. In many cases, the extra inch of water applied may not only prove to decrease profit, but may also even work to decrease yields. This is especially true when irrigation water is applied late in the season on cotton. If we look at the profit per acre per inch of water curve, we see that the same profit level is attained by applying 4 inches of irrigation water or 12 inches of irrigation water. In nearly every case, the cotton crop is also much more reliable at the 4-inch irrigation level. Irrigating to meet the peak profit point or to the left of the peak profit point will ensure that the water resource is used in the most effective and responsible way, promoting sustainable, economically sound production agriculture. This video is delivered by cooperative support and funding from the Texas AgriLife Extension Service, the Ogallala Aquifer Project, and the Texas Water Development Board.